In last video, we wrote equations of graphs based off of a verbal description of how it had been shifted, changed, compressed, stretched, reflected. Now I'm going to take an equation and match it to its graph. So before we start matching, notice that all of these have an x squared component with it. So all of these have a key graph of y equals x squared. Okay, so what does that graph look like when it hasn't been moved at all? It will be a U-shaped parabola opening up where its vertex is right here at the origin at 0, 0. So let's keep that in mind as we talk about these graphs. So example 2 reads, match each graph to one of the following functions and give the coordinates of the vertex of the graph of the function. Okay, personally, I think giving the coordinate of the vertex is really silly, but your homework asks for it, so we're going to do it too. So part A, we have x squared plus 2. So what does this plus 2 do? Well, if we look at our previous page here, when I have a plus 2 or a plus anything on the outside of that function, that shifts it up. So this is going to make this shift up 2 units. So which one has a parabola opening up, but that vertex has been shifted up 2 units? And it's going to be this one right here. Okay, that vertex was at the center, or was at the origin, and now it's here at 0, 2. Now this one has something very similar. It still has that plus 2 outside that function, outside of that squared. So it's still going up 2, but now I have a negative out front. So what does that negative do? When I have a negative in front of that function, it reflects across the x-axis. So reflecting across this x-axis makes this, instead of concave up, now it will be concave down, which when we went over graphing quadratic, we talked about a negative a value and how it makes it open up instead of down. Refocus that. There we go. Okay, so which one has still been shifted up to, but now is upside down, and that is this one right here. It has still been shifted up to, so the vertex is still at 0, 2, but now it is concave down. On C, we have a -2 on the inside of the function. I can tell it's inside because it's part of that squared. So when I have a minus inside opposite, it's going to shift it not towards the negative numbers, but towards the positive. So this is going to the right too. So instead of having a vertex right here at 0, 0, which one has been shifted over 2 units? And that looks like this one right here. So now my vertex is at 2, 0. Now this one, because it's got a plus on the inside, now it's going to go to the left, which is what it has here. If it's a plus inside that function, it's shifting to the left, and again, inside opposite. So that plus needs to go towards all those negative numbers. And again, this negative outside means it's concave down. So which one is facing down and shifted to the left too? And that looks like this one right here. So this one is D. And this is at -2, 0. And then these two are almost identical. These have both been stretched by a factor of 2. But because this one is positive, it's going to be concave up. And because this one is negative out front, that makes this one concave down. So concave up is E. And this vertex is still at 0, 0 since it hasn't been shifted up, down, left, or right. And then here, this would leave that to be S since it's concave down. And again, a vertex at 0, 0 because it has not been shifted up, down, left, or right.